This is 6.1 part 1, the law of sines. We're going to combine this with chapter 4. That's where it fits in. So what is the law of sines? The law of sines is going to be used essentially to solve non-right triangles. Before, when we had right triangles, you would use SOHCAHTOA, and a big mistake that students make over and over again is even with a non-right triangle, they think that SOHCAHTOA still really applies, and it doesn't. You have to have a right triangle to use your sine, cosine, and tangent with the opposite hypotenuse, adjacent hypotenuse, opposite adjacent, etc. So we will be using the law of sines to solve non-right triangles. So we have a few different cases, but let's first get into exactly what the law of sines is, and you can see this on your paper. We have the sine of A, that's angle A divided by A equals the sine of B divided by B, and then the sine of C divided by C. But when you look at your triangle, let's make sure that we label it correctly. Make sure that your opposite of your angle, notice we always do angles. Angles are always, not sure what's going on there. Angles are always uppercase, and sides are always lowercase. And then we should always be making sure that they correspond to the opposites of each other. So notice angle A is opposite to side A, angle B is opposite to side B, and then angle C is opposite to side C. So it's important to do that. Now when you're looking at the law of sines, and this will make more sense when we go through an example, but you only need to use 2 of these at once. Okay, so we're not going to use all 3 at once. We're just showing that they're all equal to each other. So the sine of angle A divided by A will always be equal to the sine of B, angle B divided by side B, or you could say it's equal to the third one as well. We don't have to do all 3 of them at once. Okay, so let's get right into an example. Oh, I'm sorry. Let's first talk about when the law of sines works. So the law of sines will only work when you have angle, angle, side. So that's the first one that you see. Angle, side, angle, or our angle, side, side, the big joke in geometry, the donkey one, and we'll talk about that a little bit later. So we have 3 situations here. Let's just label what that would maybe look like. So if we have the angle, angle, side postulate, that means that we have 2 angles in a row and then a side. So angle, angle, side. Obviously, we could rewrite it however we want. It could go angle, angle, side, angle, angle, side, as long as it's 2 angles in a row and then the side. Our second example would be angle, side, angle, and that one's pretty easy, like if you had angle and then a side and then an angle. So an angle, 2 angles with the side in between. And then our last one, the angle, side, side, that's where you have 1 angle and then 2 sides in a row. We're not going to really talk about this one today. We're going to talk about this one in part 2 because it's a little unique and a little bit more difficult. So that will be part 2 of this section. What we're going to do is focus on angle, angle, side, and angle, side, angle. So let's get right into the example now, and you'll see that the law of sines is actually a really, really easy concept to do. So in this example right here, you should see that we have an angle, and then a side in between that. So in this example, we're talking about angle, side, angle, so the law of sines does apply. So what we want to do to start this problem off is we just want to label. It says solve the following triangle. So let's just label everything. A equals, B equals, C equals, and then little a equals, little b equals, and little c equals. And then what we can do is, this is solving, finding all 3 angles and all 3 sides, so label what we know. So we have what angle A is. Angle A is 110 degrees. We have what angle B is. Angle B is 20 degrees. Okay, we don't have C, or C is not given to us. We don't know what side A or side B are, but we do know what side C is. That's 25 centimeters. So what we want to be clear about when we're doing this is we need to make sure that we have a pair. We have to have a full pair to use the law of sines. In other words, we have to have at least 1 angle and its corresponding side to be able to do this. So in this case, we don't have it, but we really do. And we really do because we have side C, we don't have angle C, but we can figure out angle C very, very easily. Because you should remember that there's 180 degrees in a triangle, so if I want an angle C, I can just simply do 180 minus 110 minus 20, and we would get our angle C is going to be 50 degrees. So we can put 50 degrees in for angle C. Now we have a full pair to be able to use the law of sines with. So when we use the law of sines, we just set it up exactly how the formula shows. So this will be, our first one will be the sine of 50 over its corresponding side, which is 25, equals, and then we can pick whatever one we want to solve first. We can't do both at the same time, but I'll just typically do A first. So that means we have the sine of 110 degrees over little a. So in this case, we now just are simply left with a fraction, a proportion that we can now solve. And we cross multiply, just like we would if it was anything else. We have this diagonal is multiplied by this diagonal. So we write that out. 25 times the sine of 110 degrees equals A times the sine of 50. And then to solve for A, which is what we're trying to solve for, we divide both sides by sine of 50. The sines of 50 cancel out. That's the whole point of dividing by it, is to get rid of it. And then in our calculator, we can put in 25 sine of 110 degrees divided by the sine of 50 degrees, and that's what A is equal to. And in this case, if you put that in your calculator, A is equal to 30.67 centimeters. So that's what we can put up here, 30.67 centimeters. And now when we want to go do angle B and side B, we do the exact same thing. We're going to do sine of 50 over 25 again equals, and now we'll do the B, sine of 20 degrees over side B, and then we cross multiply again. So we have 25 sine of 20 equals B sine of 50. Once again, we're going to divide both sides by sine of 50. And everything now is all calculator work. So once you have your proportion and you isolate your variable, you're just putting the rest in the calculator. You put this into the calculator and you get 9.73 centimeters. And then you just want to make sure you double check. Make sure the smallest angle corresponds with the smallest side. Largest angle corresponds with the largest side. Everything checks out there, so we're good. Okay? So that's an example of an angle side angle. But honestly, once you have a corresponding angle and a corresponding side, you can use the law of sine. So it's not really you have to pay attention to the angle side angle or the angle side or the angle side side. You just need to understand whether you're given enough information to use the law of sines or not. So for this next example, I'd like you to try this one on your own. This is an example of a angle side one, but it doesn't change that you can still do this using the law of sines. So I would like you to solve this right triangle, or not right triangle, solve this triangle, and what you're going to do is put in all of your answers, like put in capital C equals capital, just put all of it in. Even though some of it's given to you in the Edpuzzle, I want you to put in everything that you find. And then let's see how you do on this. So here's the solution for this one. Of course, you use the law of sines right off the bat to figure out what A is. We have sine of 55 over 8 equals sine of 30 over A, and then cross multiply and divide to get our A equals 4.88. To figure out angle B, we would subtract from 180, 30, and 55. We get 95 for our angle, and then we can use that angle to do our law of sines for side B. So sine of 55 is to 8 as the 95 degrees is to B. And then cross multiply and divide and get 9.73. So hopefully that makes sense. We will do the angle side, the donkey version in part 2, which will be the next section that we do. So hopefully this makes sense. I will see you in class and hope you have a good night, day, morning, class period, wherever you find yourself watching this. So I'll see you in class.